and welcome to today's lecture. Our course title is Probability and Statistics. And I'm sure if you've gone onto the LMS, you will see that it has been mounted. I don't know about okay, this is the diploma class. I'm not too sure. I'm yet to check up. So let's start, even though I see about 1, 2, 3, 4. Okay, the others are joining. So let's continue. Today will be just introductory to the course. So I may not engage you more on calculations. We'll take our time and walk through our plan for the semester and then how we are going to apply it to our information technology. So you guys are doing IT, and IT, we all know, is information technology. So we want to break it down to see the reason why you are doing this course, probability and statistics. So information technology, two words joined together. Now, if we check into details, we need to find out what information is and then what technology is. Okay. Technology can simply be defined as the application of science to solve problems. So application of science to solve problems. All right, so this is clear here. Now, what about the first word, information? Now, information can also be simply defined as processed data. Processed data. So it means that if I'm to just put the two together in a simple language, all that you will be doing in this your program, information technology program, is that you will be applying process data with the aid of science to solve problems. In other words, if I pull two words from the two definitions I've given you, it means basically your program is about data and science. It's about data and science. Okay. That is why you are doing the programming languages, C++, and the rest that you do for the science. And then the data, one of the courses that you would do to enhance your knowledge on data and data processing is this course we are taking this afternoon, probability and statistics. So it is very important to understand the basics of this course so we can relate it to your program of diploma in information technology. Before I move deeper into the course, let's look at some fundamentals. Now, I know you are new in this course. You've done just one semester. This is your second semester. But there are some IT situations you come across very soon in the program, either currently in the diploma or when you start the top up. You will see that we have certain areas called random number generation. We have simulations. If you haven't heard about them, you hear about them. We have data analysis. We have machine learning. We have development and performance benchmarking. All these are areas that need the application of information technology. So several of the AI decisions you'll be seeing in your area, you'll get to know that it's a combination of the courses we are doing now. The probability or statistics can be applied through the use of the C++ programming to be able to generate results or decisions. And like I said, as we go along, you apply either one of them at a time, like you are seeing here, or you can apply both, especially in machine learning. You apply both at the same time. It has a wider application. Then, if that is the case, we need to understand them before we can proceed with further work on them. That when you hear about probability, what comes into your mind? When you hear about statistics, what comes into your mind? And then why is it sometimes necessary to combine the two at the same time? Now, probability, by definition, like I've stated on the screen, and I'm sure you are seeing it on your phone or the electronic device you are using. Probability is all about predicting how likely, okay, how possible something is to happen. That is probability. Probability is about predicting or guessing, okay, predicting or guessing how something is likely to happen. So, for instance, you know the season we live in now. Now, you can't even predict whether it will rain today or tomorrow until the weather changes. But you are very attentive that it can rain anytime. That's your prediction. Your prediction is that it can rain anytime. So when somebody tells you it will rain today, you will not doubt the person. You will believe it because of the kind of season we are living in. And sometimes people just guess and it comes to pass. They predict and it happens. But the fact that you have predicted doesn't mean it will always happen. Okay, the fact that you have predicted doesn't mean it will always happen. So, some simple phrases we can use to understand probability more is that probability can be any event. Probability can be any event in which the event may, so these are the two possibilities, may occur or may not occur. That is why it is called a guess, a probability. You are guessing. to see whether you get it right. So in information technology, we use probability for future data. We use probability for future data. That is data that we don't know, but we are going to guess. We use probability to predict future data. Now, if we use probability to predict future data, then it means we can also have a past data. We can have past data, and then we can also have present data. Present data. It's just like the way we have yesterday, and then we have today, then we have tomorrow. So the type of data I have written at the other side, just to be explaining what we want to do, I'm saying we have future data, we have past data, and then we have present data in information technology. How do we handle these three types of data? The first one, probability, is saying that it's about predicting how likely or how possible something is to happen. And I'm saying because the thing hasn't happened, it is falling under future data. We are yet to know it. So it's like tomorrow. Probability is like tomorrow. We don't know tomorrow. But the fact that we don't know tomorrow doesn't mean we shouldn't guess about tomorrow. So we use probability to guess about tomorrow or something that is likely to occur. And that falls under future data. Then the other aspect of the course, statistics. Statistics also handles yesterday and today and not tomorrow. Statistics handles past data and present data. The definition of statistics is that statistics is the process of collecting data, analyzing data in order to see what is happening. I repeat, statistics in a simple explanation is the process of collecting data and analyzing data to understand what is happening. The first one is predicting about something that can happen. This is what is happening. So this one is happening or it may have happened. And this is where the past data comes in. So you analyze past data and present data using statistics, and then you analyze probability you analyze future data using probability. Somebody may say, so can we do away with one of them? No. We need a combination of the two in order to be accurate in our processing of data. We need to combine the two. in order to be accurate. So, for instance, if you want to know about tomorrow, you need the history of yesterday. You need the history of today. And that can help you what can happen tomorrow. That is why you can't separate tomorrow from today. And then you cannot also separate today from yesterday because they are interlinked. There is a relationship between yesterday and today. And there's also a relationship between today and tomorrow. That is why we have probability and statistics. We need to link the two, which is very, very important. So, sorry. So it means that we will need the two to be able to analyze accurate data. To really paint a better picture for you as to why we need the two, this is what I'm saying here. I'm saying probability and statistics are closely related. They are like the two sides of the same coin. They are like the two sides of the same coin. So if you have a coin and this is the front view of the coin, and this is also the back view or the real of the coin. Like the way I have drawn it, you don't have a coin whereby the first side is bigger than the second side. For the same coin, you have the same diameter. So if I have a coin this way, and then the other side also looks same as this, when you join the two, then the image of the coin changes to look something like this. So you get this going this way to the other side. So that the bottom one will represent the rear side, and then the upper part will represent the front side. And that is how we can relate probability. Probability is up here, statistics is down here. What do? They analyze data of three types: future data, past data, present data. And that is the course you have to take before we can do some bit of data analysis. So this is the short explanation I can give to you about probability and statistics and the reason why we have to do the two at the same time. All right. So let's look at some examples. I go further by saying that probability helps you to make smart guesses about the future based on chances because you are not sure. So anytime you guess, it's like you are trying your luck or something. Okay. Now let's look at this example. What is the chance that a user forgets their password today? Is there a chance that you can forget about your password? Yes, there is. Because sometimes you have created a lot of passwords and then you don't know which one you used in accessing a system. So you keep trying the passwords you have used before until probably you become successful. When you are doing something like that, we say you are undertaking the activity of probability. You are trying to check the chance to see whether your password is working or not. And is there a chance also that you may not forget your password? Yes, there are some people who stick to only one password. So no matter what you do, they are just using one password. There's no way they can forget about it. So probability is all on chances. And the chances sometimes can be 50-50 or 50%, right? Then again, another explanation, statistics helps you to understand what happened in the past. Statistics helps you to understand what happened in the past. Probability doesn't help you to understand anything. It helps you to rather predict or guess. But statistics helps you to understand what has already happened. So what happened in the past by looking at the data. Example, how many users logged in this week and how long did they stay online? I mean, this one should be simple for you. If you're an IT person and you are monitoring the logins of users, you are monitoring the logins of users. I mean, the records are there, their credentials will register. So if you had 200 users yesterday, it is there. Those who came online also, if out of the 200, about 130 came online, that one also is registered. So in order to understand such things, you use statistics because you have the data already. And we call these ones the past data. It is not present data. It has happened already. It is not future data. It's not about to happen. Now, in building systems, like you do in future as IT professionals, you'll be building systems or softwares. And I know you started with a diploma. By God's grace, you proceed from the diploma to the top up. You do the top up, and then you have your first degree also. You have your diploma, and then you may have your degree as well if you do the top up. So definitely you build systems, even if you don't build systems during your diploma class. When you start your degree, you build a system. So in building computing systems or IT systems and then developing softwares, there is one key thing that is used, and that thing is called data. Okay, it's called data. And we can have data from so many sources. We can have it from users, you can have it from servers, you can have it from other devices. Once they represent data, it is data. And data by definition, like you know from JHS, data are raw facts. Data are raw facts. Okay. Now, how do you then work on these raw facts? We'll use what we are talking about to today, we always use to work on data. So for instance, if you are building a system that will detect problems, you still use data. And once you are using data, statistics and probability will be in action. Anytime data is used in building some of these systems, statistics and probability will be used as tools. Then it means that in all systems that we build, whether from IT or IS, we do some of these things that helps us to understand probability and statistics. Sometimes you'll be taught how to analyze user behavior. You also be taught how to understand security systems. You also be taught how to understand network traffic, and then how machine learning is also used. Underneath all this, or the basics also all this, is that you can always use statistics to analyze user behavior. That is why we need to understand statistics, where we want to understand what has already happened or is happening. Security systems, the hacking and the scammers and the rest, sometimes we can use probability to be able to detect their activities or actions. Network trafficking can also be analyzed using statistics. Machine learning will use both probability and statistics to train something we call smart systems to make decisions. And I'm sure some of these things are new to you, but don't worry at all. All these things you'll be taught along your academic journey. So if I'm to write a sentence to describe how probability and statistics helps in the IT area, one of the ways is that we can say probability and statistics gives you the tools to make sense of data or to understand data, to predict outcomes or to predict tomorrow, and to improve the way technology systems work. If you want to understand the way technology systems work, then you have to get your fundamentals properly from probability and statistics. I'm showing you all these for you to know that we are not here to just come and do some calculations and go away. But we are here in this course to have some fundamentals in probability and statistics that can enable us to understand the complex ICT systems that we can come across in our journey. So once today is introductory, let me then show you our plan, which I call the roadmap for the course. The roadmap for the course shows us where we are starting from, how we are moving, and then where we are getting to, which is very, very important. And so there is a lot of data or abundance of data in this world. Data can be sourced from so many places. And you and I know that if you go to the education sector, you get a lot of data. If you move to our hospitals and clinics, in the same manner like education, you get a lot of data. If you move to the engineering industries, we have abundance of data. If you go to the mining areas, I mean, data is like gold. You can really find it where you want to. But unfortunately, data itself is not useful unless you modify it before you use it. That is where we have the challenge. Data itself is not useful. So we say data are raw facts. They are raw facts. If you want the use of data, it means you need to change it into information, like you're seeing here. Once we get information, then we can change the information to decisions. And this is where you have the AIs. This is where you have the AIs. Once you have the information, then you can develop the AI models, all starting with data. And then you end up with decision activities to enhance the IT. So if we say data are raw facts, and then information are processed data, and then decisions are processed information, how are they connected? And this is what I can do to help you. If you take a coconut that we all buy from the roadside, coconut can be on the ground like this. You can step on it, your leg can be on it, like the way the coconut sellers always try and arrange them on the floor. And we see, okay, I'm sure when you want to buy this coconut and the coconut seller just tells you to just take it, and then you can start chewing from the back, I'm sure you may think the guy is crazy. Because why? The coconut in this state is raw. Okay, it's raw. But the good thing is that the coconut has 3 layers. You have the first layer, you have the second layer, you have the third layer. And that is where you have the coconut juice. Okay. So the coconut with its outer covering, like this, is raw. And that is how data looks like. So data is raw. Okay. But information is not raw. Information is refined. Now, what is the information here? The information we need in this coconut is the coconut juice, where I have colored red. The coconut juice is what we need. And that is the information. So with this example, then it means that information is hiding in data. And once we are able to crack data, it means we can get information out. And that is one thing that is going to help us, that for every data that we see, information is inside the data. So information is in data. So like I said, once we crack open the data like this, by the way the coconut sellers start peeling. So they start peeling this side, this outer cover. They keep coming gradually. They keep coming gradually. They get to where I have drawn the line, and then they get closer to where the juice is. That's the information line. And once they crack that place open, you see the juice coming out from the coconut. And that is how we can recover information from data. That is how we can get information from data. It means that we shouldn't leave data in its raw state. We should be able to crack data to get access to the information. So our plan for this semester is as follows. Anytime we get our data, we crack the data to get information. Now, once we have the information, we don't stay there because we need the information to take decisions. So out of the information, then we are able to pick our decision in the long run. In short, information is processed data or data that has been processed, and then decision is also information that has been processed. Information is processed data, and decision is processed information. Some of the tools that are going to help us to understand this in probability and statistics are the ones that are in the yellow region. So we'll learn more about a concept called central location, followed by dispersion, position, and shape. They are all talking about data. The first one will teach us about the center of data. The second one will teach us about how data is spreading out from the center. The third one will show us how data can be divided into various divisions. And then the fourth one will teach us how the shape of data can be arrived at. Then we'll continue with some other sets. We'll do probability distributions, sampling distributions, parametric testings, non-parametric testings, regression analysis. And I'm sure by the time we are done with this, we'll then understand why this course is part of the program you are undertaking. So finally, I will relate the two in the roadmap, and then I can open the floor for your questions. Today is introductory. And so by 2:30, I'll be done, and then I'll open the floor for your questions. All right, so in IT, what are raw facts? In IT, anytime you have raw logs, sensor outputs, user clicks, network packets, database entries, all these are raw facts. So they represent data. An example is when a web server logs showing request timestamps, IP addresses, and response codes. I'm sure some of these are technical words for you, but don't worry, you are doing IT, so you come across them one of these days if you haven't heard of them before. Information is processed data. So how do you see that one also in IT? Okay, so in IT, anytime you collect logs, or data. It is cleaned, processed, and it is used to produce information. And there are some information you learned about website traffic patterns. And some of this second example, intrusion detection alerts, you know some of them already. They are all information that will be given to you by the system. So if you have a system, if you have an IT system, this is how it goes. If you have an IT system, you see that an input will come through the system, and then the system will give you an output, which is information. So you have data here, you input data here, and then you output information. Because the data has been processed by the system. So you have information. Right. Now, what about decision? There were three things I did. I said the roadmap, we are moving from data to information. And then from information, we move to decision. So some of the process information or decisions you can see in IT are as follows. I don't know whether you've come across some of them yet. We have system optimization, example is reducing server response time. We have security threat detection, intruders. We have user behavior analysis. And then we have capacity planning in cloud systems. Don't worry about these things if you haven't heard about them before, but these are all technology activities, which I'm saying with the help of probability and statistics, we can understand the nature and how they happen. So in concluding for today, until we continue next week, this is how I want to end the class. Now, statistics and probability in IT is like a two-way bridge. It's like a two-way bridge. You need the two at the same time. You need the two at the same time. You can move from statistics to probability or probability to statistics. And from next week, we will learn about sample and population. Sample and population. It is easier dealing with sample than population. And these help us to understand some of the things that happen in IT. Now, the two-way bridge that I talked about, this is how it works. I started by saying that statistics helps us to understand the past and the present. Okay. And then probability also helps us to plan for the future or to guess for the future. Now, these two are linked like a bridge in IT. So in IT, the link between statistics and probability forms the foundation of data-driven decision-making in IT. examples are network management. You have to apply statistics and probability in a two-way bridge. System reliability, which is the characteristics of a good system, also depends on statistics and probability. The popular AI, artificial intelligence, also depends on statistics and probability in a two-way bridge. And then cyber security also does same. If I were you, I'll spend time to read on network management, system reliability, artificial intelligence, and cyber security. If you have knowledge about these areas, it will help you appreciate the statistics and then the probability you are undertaking, so that it wouldn't be like we are just doing some maths, but you know that whatever we are doing is a foundation for your information technology course. So on that note, I would like to end on this page or this side, so that the next time round we can start from the data proper, how we can have our data sources, and then how we can process the data. At this point, the floor is open for your questions. Any question about what we have done so far in probability and statistics? If you have a question, please put up your hand and let me address your question. Any question? Any question? Any contribution? All right. So once you are doing this program, it means you are serious to understand IT. So in your own time, I'm recommending that read about what I have underlined here. Foundations of data-driven decision making in IT. Then you pick the areas. Network management. You just want to understand it. Like when somebody asks you, what is network management? What can you say? You need to understand it before you can respond to the person. What is system reliability? Even though you know about AI, when somebody asks you a spot on question, what is artificial intelligence? How are you going to respond? And then cyber security. So that as we relate our class to some of these concepts, you will not be lost as we move along. So I will end on slide 15, and then God willing, when we meet next week, we'll continue from slide 16. If there is no question for today, on that note, we will end the class and then adjourn it to next week, 1:45 p.m. I wish you a good weekend. The class is officially ended.